Imagine standing at the edge of a vast canyon or gazing out over a seemingly endless ocean. Now picture a bridge stretching across, not touching the ground below, yet standing tall as if by magic. How could something like this exist? Welcome to the world of groundless bridges, an engineering breakthrough where the impossible becomes reality. These revolutionary structures push the boundaries of what we know about construction, architecture, and even gravity itself. Curious to know how it works? You're in the right place. But before we dive into this mind-blowing topic, don't forget to give this a quick like and subscribe. It helps us bring you more incredible stories like this one. All set? Let's get started. Unlike traditional bridges, which rely on firm foundations drilled deep into the earth, groundless bridges float, suspend, or balance themselves without anchoring directly to the ground. Picture a suspension bridge where the cables don't need massive anchorages, or a floating bridge that gently rests on the surface of a lake. These designs are more than just futuristic, they're already being built. Take the Evergreen Point Floating Bridge in Washington, for example. This engineering wonder spans over 2.4 miles, supported entirely by pontoons. Its design allows it to traverse a deep, unstable lakebed where traditional bridge foundations simply wouldn't work. Or consider a self-anchored suspension bridge, where cables attach directly to the bridge's structure instead of distant anchor points. These bridges balance their own weight, creating a dynamic, self-sustaining system that's as efficient as it is breathtaking. Building a groundless bridge requires a combination of cutting-edge materials, precision engineering, and state-of-the-art technologies. Here's how these components come together to create structures that's as efficient as it is breathtaking. The strength and stability of a bridge depend on its materials. Traditional steel and concrete are giving way to high-performance alloys and composites that are lighter, stronger, that seem to defy gravity. For instance, carbon fiber reinforced polymers are increasingly used in suspension cables because they offer incredible tensile strength while remaining lightweight. Artificial intelligence plays a crucial role in the design and maintenance of groundless bridges. AI algorithms analyze complex variables such as wind pressure, traffic loads, and seismic activity to optimize load distribution across the structure. This ensures stability and minimizes stress on key components, even under extreme conditions. Groundless bridges often rely on innovative suspension systems where tension and compression forces are carefully balanced to maintain stability. Floating bridges, on the other hand, use buoyant pontoons to distribute weight evenly across water surfaces. These designs not only reduce the need for invasive construction, but also allow for flexibility in challenging environments. Modern bridges are equipped with sensors that provide real-time data on structural health. These systems can detect even the slightest shifts in tension, pressure, or alignment, allowing engineers to address potential issues before they become critical. Why invest in groundless bridges? The answer lies in their potential to transform connectivity and infrastructure on a global scale. One of the biggest advantages of groundless bridges is their ability to span previously inaccessible regions. Deep valleys, unstable seabeds, and remote islands are no longer barriers to connectivity. This opens up new possibilities for trade, travel, and economic development. Traditional bridge construction often involves significant disruption to the natural environment. Piling foundations into riverbeds or drilling into mountains can harm ecosystems and displace wildlife. Groundless bridges, by contrast, are designed to minimize these impacts. Floating bridges, for example, leave underwater ecosystems largely undisturbed, while self-anchored designs reduce the need for massive excavations. As sea levels rise and weather patterns become more unpredictable, traditional infrastructure faces increasing risks. Groundless bridges are uniquely positioned to address these challenges. Floating designs can adapt to changing water levels, while advanced materials and AI-driven systems ensure resilience against extreme weather events. While the concept of groundless bridges is undeniably revolutionary, bringing them to life is no small feat. These cutting-edge structures, which push the limits of traditional engineering, come with their own set of formidable challenges. Without the support of solid foundations, groundless bridges face unique safety challenges. These structures must endure and adapt to a range of dynamic forces, including high winds, shifting waves, and seismic tremors. The absence of traditional anchoring systems makes them particularly vulnerable to external pressures. For engineers, the stakes couldn't be higher. Any structural failure could lead to catastrophic consequences, jeopardizing both human lives and the future of such ambitious projects. Ensuring these bridges remain stable, secure, and dependable under all conditions is an ongoing and complex task. The price of innovation is steep, and groundless bridges are no exception. Developing and constructing these engineering marvels demands cutting-edge materials, advanced technologies, and highly skilled labor, all of which drive costs into the stratosphere. For instance, the Evergreen Point Floating Bridge, a pioneering example of a floating structure, cost over $4 billion to complete. With such significant financial investments, stakeholders often grapple with a critical question: do the long-term benefits outweigh the initial expense? For many regions, the cost may prove a prohibitive barrier to entry, limiting the widespread adoption of these futuristic designs. Although groundless bridges are often praised for reducing invasive construction practices, they are not entirely free from environmental concerns. Floating pontoons, while minimizing disruption to riverbeds or seabeds, can still interfere with aquatic ecosystems. Additionally, the reliance on advanced materials like carbon composites and specialized alloys raises concerns about resource depletion and environmental sustainability. The challenge lies in finding a delicate balance, achieving groundbreaking innovation without causing undue harm to the natural world. Striking this equilibrium is vital if groundless bridges are to fulfill their promise of eco-conscious progress, from their susceptibility to environmental forces to their sky-high costs. Groundless bridges highlight the complexities of modern innovation. Yet, each challenge also represents an opportunity for engineers to pioneer safer designs, for researchers to develop more sustainable materials, and for policymakers to find creative ways to fund and support such transformative infrastructure. Groundless bridges, while not without hurdles, reflect humanity's relentless drive to overcome obstacles and reshape the limits of possibility. With careful planning and continuous innovation, these challenges could one day transform into milestones on the path to a more connected and sustainable future. Groundless bridges are more than just engineering feats. They're pushing the boundaries of what's possible. Could these bridges pave the way for an entirely new era of infrastructure? Imagine bridges that span vast oceans, connecting continents and creating new global networks. Picture floating highways that adapt to rising sea levels, or suspension bridges that gracefully arch over the most rugged terrains. But with great ambition comes great responsibility. As we embrace these innovations, we must also address the ethical, environmental, and economic implications they bring. Will groundless bridges prove to be the future of connectivity, or will their complexities outweigh their benefits? Let us know your thoughts in the comments below. Thank you so much for watching, and we'll see you in the next one.